Today we will be simplifying by factoring, and factoring should not be anything new for you. We're just going to briefly review it. I'm going to start off with some pictures. For me, it's easier to see with pictures. And then we're going to use what we've learned here and use some rules of exponents and try some harder problems. So when we're factoring, we have to find our two groups. Sometimes there's going to be more than two groups, but in this case there's only two groups. The groups are separated by a plus or minus sign. And when we factor, we're trying to find what's the largest amount that we can take equally out of both groups. Okay, so we have a half of an orange in the first group and 1.5 oranges in the second group. The largest amount that we can take out equally from both groups would be a half of an orange. So let's write that down. In the first group we have 5.5 apples, and in the second group we have 1.5 apples. The largest amount that we can take out from both groups equally would be 1.5 apples. The second group also has some bananas, but the first group doesn't, so I can't take out any bananas. Let's see what's left. From the first group, if I took out a half of an orange, no orange would be left. And if I took 1.5 apples out, there would be 4 apples left. There's a plus sign between these two groups in our original problem, so I'm going to keep that there. In our second group, if we took out half of an orange, we would have 1 orange left. And if we took 1.5 apples away, there would be no apples left, but there are still the bananas left. And that's it. And that's all there is to factoring. So let's review quickly our rules of exponents, and then we'll try our problems. The properties of exponents, if you don't remember these, please search it online and try a couple problems. It's very important that you know how to do the properties of exponents. So the first example here, my base is x. I'm multiplying these together. The properties of exponents say when I have the same base and I'm multiplying them together, all I need to do is add my exponents. So my exponent is 3/2 and 1. We don't really write the 1 if we don't need to. If you have a hard time with adding 3/2 and 1, change it to 2/2. So 3/2 plus 2/2 is 5/2. This is pretty much identical, the second problem, to the first problem. The only thing that's changed here is our base. Our base is now 2x plus 3. So again, if we have two bases and we're multiplying them together, we add our exponents. So my final answer would be 2x plus 3 to the 5/2 power. Now down the road I might try and trick you and put a plus sign in between. Be careful. The rules, the properties of exponents apply when I'm multiplying the bases together, not adding them. So in this case, the quantity 2x plus 3 to the 3/2 power and the quantity 2x plus 3 are not like terms, and I cannot combine them in any way. So this would be not true. Be careful. Same thing, same base, same thing I need to do when I have a negative exponent. I still have to add my exponents together. So 3/2 plus a negative 1/2 would be the same thing as 3/2 minus 1/2, which would be 2/2. And always simplify your exponents. 2/2 is the same thing as 1. Last thing I want to mention here, we never write mixed numbers for exponents. Always keep your exponents as an improper fraction. Okay, I'm only going to show you 2 examples today. They're both pretty challenging, but I think you can do them. So anytime while you're watching this video, put the video on pause, try and work ahead if you can, anything you can do to help yourself. So for me, I like to look at my 2 groups, and again they're separated by a plus sign. We have the first group has a whole bunch of numbers in it, same thing with the second group. We're trying to see what is common. The first thing I notice is that both groups have just a number in front, a 3 in the first group and a 10 in the second group. The factors of 3 and the factors of 10, there's nothing common except 1, so we don't need to factor out a 1. It wouldn't really help us. So there's nothing to factor out from between the 3 and the 10. But the x plus 1, if you look, it's common. The base is common in both terms, so we definitely can pull out an x plus 1. What's our exponent here? Well, In the first group, we have an exponent of 1/2, and in the second group, an exponent of 3/2. So the largest amount I can pull out equally from both groups is 1/2. Okay, look at the exponents, find the smallest amount. The last thing in both sets, we have the same base of 2x minus 3. 2x minus 3, we can definitely pull that out. How much? Well, in the first group, we have 5/2. And in the second group, we have 3/2. The smallest amount is 3/2. So we're going to pull out the quantity 2x minus 3 to the 3/2 power. When I'm pulling it out, what I'm really saying is I'm going to subtract it or divide it. So let's see what's left. In the first group, we have a 3 left. If we had x plus 1 to the 1/2 power and we're pulling out an x plus 1 to the 1/2 power, we don't have anything left. If we had a 2x minus 3 to the 5/2 and we're pulling out a 2x minus 3 to the 3/2, we're going to subtract those exponents. 5/2 minus 3/2 is 2/2, and 2/2 is the same thing as 1. Okay, the second group. Remember, you have to put that plus sign in between because it was in the original problem. So we have a plus 10. We didn't factor anything out of the 10. The x plus 1 to the 3/2, we factored out a 1/2. So if we are factoring it out, we're going to subtract our exponents. 3/2 minus 1/2 is 2/2, which is 1. The quantity 2x minus 3 to the 3/2, we factored all of that out. So this is what you have left, and this is the hardest part of the factoring. All we have to do now is look at the second part, the last part that we did, and clean that up a little bit. We have to distribute the 3, distribute the 10, and combine like terms, and that's it. So this would be your answer. We simplified this as far as we could using factoring. Okay, here's our second example. Again, if I were you, I would pause the video and try it on your own first. So if you look at the two terms, again, in this case, they're both separated by a plus sign. I see that I have an x plus 1 in both terms, so I'm going to factor that out. The smallest exponent in this case is a negative 1/2, so I'm going to factor out an x plus 1 to the negative 1/2. And the quantity 2x minus 3, the smallest amount, has an exponent of 3/2, so that's what I can factor out. So let's take a look at our first group. We factored out the base of x plus 1. So let's look at the base of 2x minus 3. The exponent was 5/2. We're factoring out 3/2. So 5/2 minus 3/2 is going to be 2/2. 2/2 is the same thing as 1. Don't forget the plus. There was a 10 there. Here's the tricky part. We had x plus 1 to the 1/2. If we factor out x plus 1 to the negative 1/2, we're going to subtract our exponents. So 1/2 minus a negative 1/2 is the same thing as 1/2 plus 1/2, which is just 1. The 2x minus 3 to the 3/2, if I'm taking the whole thing out, there's nothing left. Okay? If you need to, stop the video and rewind it. You can listen to this again. In the brackets is the only thing we can simplify right now. And one more step. So this is simplified as far as it can go. I would probably give you full credit for this, but the answer you will most likely see is with all positive exponents. One of the properties is always to try and make your exponents positive, and the way to do that is just to move it. If it's in the numerator and it's a negative exponent, you're going to have to move it to the denominator. So the only negative exponent was the negative 1/2. If we move it to the bottom, it becomes a positive 1/2, and that's your final answer. Come see me if you're having trouble.